In question 3a, we're given the coordinates of 3 points and asked to find the area of the triangle with these vertices. There's a result in the formula book which says that the area of a triangle is a half times the absolute value of x1, y2 minus x2, y1. However, there's an important caveat here. To use this formula, we must translate the points so that one of them becomes the origin, 0, 0. Here, I'll perform a transformation to our first point, 4, 6, so that it gets mapped to 0, 0. We begin with an x-coordinate of 4, and we want an x-coordinate of 0. So the shift here is minus 4. We start with a y-coordinate of 6, and we want a y-coordinate of 0, so the shift here is minus 6. So the overall translation is minus 4 to the x-coordinate and minus 6 to the y-coordinate. This translation should also be applied to our other 2 points, minus 3, minus 1, and 0, 11. Minus 3 minus 4 is minus 7, and minus 1 minus 6 is also minus 7. So minus 3 minus 1 gets translated to minus 7 minus 7. This gives us the x1 and y1 value for our formula. 0 minus 4 is minus 4, and 11 minus 6 is 5. So 0, 11 gets translated to minus 4, 5. This gives us the x2 and y2 values for the formula. Now, let's sub in our values. x1 is minus 7, y2 is 5, x2 is minus 4, and y1 is minus 7. When we perform the calculation inside the absolute value, it comes out as minus 63. To find the absolute value of a number, we turn it into its positive version. So the absolute value of minus 63 is plus 63. A half times 63 is 31.5, so the final answer for the area of the triangle is 31.5 square units. In part B, we're presented with 2 points, A and B. We must show that the midpoint of the line segment AB is a specified value. Well, the formula book contains a result about the midpoint. It's equal to x1 plus x2 over 2, comma, y1 plus y2 over 2. Our first point is A, which is equal to minus 1, comma, k. We'll label the minus 1 as x1 and the k as y1. Our second point is B, which is equal to 5, comma, L. We label the 5 as x2 and the L as y2. Let's sub these values into the midpoint formula. The x-coordinate can be simplified here. Minus 1 plus 5 is 4, and when we divide this by 2, we get 2. So we found that the midpoint is 2, comma, k plus L over 2. These are precisely the coordinates we needed to obtain. In B part 2, we are given the equation of the perpendicular bisector of AB. We need to use this to find the value of L and the value of k. The first thing to observe here is that the midpoint of the line segment AB will lie on the perpendicular bisector. This is because the perpendicular bisector goes exactly halfway between A and B. In the previous part of the question, we found that the midpoint had an x value of 2 and a y value of k plus L over 2. Since the midpoint lies on the perpendicular bisector, it must satisfy the equation of this line. 3x plus 2y minus 14 is equal to 0. 3 times 2 is 6, and the multiplication by 2 cancels the division by 2. 6 minus 14 is minus 8. And if we add 8 to both sides, we end up with k plus L is equal to 8. I'll label this equation 1. The strategy here will be to obtain a second equation in k and L, and then use simultaneous equations to solve for these variables. To obtain our second equation, it's useful to think about slopes. There's a fact that says the slope of the line ax plus by plus c is equal to 0 is minus a over b. The perpendicular bisector has an equation of 3x plus 2y minus 14 is equal to 0. So here we have a 3 in the slot of the A and a 2 in the slot of the B. It follows that the slope of the perpendicular bisector is minus 3 over 2. By definition, the perpendicular bisector of AB is perpendicular to AB. It follows that the slope of AB is plus 2 over 3. This comes from the fact that a perpendicular slope can be obtained if we flip the fraction and change the sign. Here, the sign changes from minus to plus, and the fraction flips from 3 over 2 to 2 over 3. So, we found that the slope of AB is 2 over 3. However, this slope can also be thought of from another perspective. There's a formula which says the slope of a line is equal to y2 minus y1 over x2 minus x1. We can apply this formula to find the slope of AB. A is equal to minus 1 comma k. We label these with x1, y1. B is 5 comma L, and we label these with x2, y2. Subbing these values in gives us L minus k over 5 minus minus 1. Since two minuses simplify to a plus, the denominator ends up as 5 plus 1, which is 6. This means that the slope of AB is equal to L minus k over 6. Earlier, we found that the slope of AB is equal to 2 over 3. So whatever L and k are, it must be the case that L minus k over 6 comes out as 2 over 3. This equation can be simplified a bit by multiplying both sides by 6. 6 times 2 over 3 is 4, so we end up with L minus k is equal to 4. I'll label this as equation 2. So, we found two equations in k and L. K plus L is equal to 8, and L minus k is equal to 4. we can use simultaneous equations to solve for k and l. The first equation has a plus k and the second equation has a minus k. This means that if we add together the two equations, the k terms will cancel. When we add the equations, the k and the minus k cancel. L plus L is equal to 2L, and 8 plus 4 is equal to 12. So we end up with 2L is equal to 12. Dividing both sides by 2, we obtain L is equal to 12 over 2, which is 6. To find k, we should sub this value back into one of our equations. If we sub L equal to 6 into equation 1, we get k plus 6 is equal to 8. If we subtract 6 from both sides, we get k is equal to 8 minus 6, which is 2. So the final answer here is L is equal to 6 and k is equal to 2.